Hi guys, welcome back. So in this video we are going to talk about the next topic, which is algorithmic science and data science. Now this is going to be a very important topic for us, because till now what we have seen is about the concepts. The concept about data science, the concept on logical thinking, the concept on computational thinking. In short, logical thinking is intelligence. Computational thinking is the study behind that intelligence, and that's what I said, the strategy and plan. The difference is plan and strategy. So every plan should have a strategy, a plan to finish the plan. So that exactly is what we are going to study in computational thinking. So when we do the computational thinking, we need to understand the step by step process, and we need to document that. That's what we have understood. Now after that, I have also discussed on the chapter called data science. So I told you how data is important, what kind of analysis we do, where and all this data analytics is used. So a lot of things we have seen. Kindly go through those videos multiple times. Okay. Now let's move on to this topic called as algorithmic science and data science. So let's first understand the concept of algorithm. So the computational thinking concept, if I am going to understand that step by step process, what the logical brain has done, now we frame an algorithm. This particular science is what Musa ibn al-Khawarizmi created, or rather understood this 1400 years back. So he said the step by step process by which the logical brain solved the process, if that you understand, if you could bring out, decompose or decode that particular thing, and write those step by step process as a document, that document is what we are referring it as algorithm. Now what are the characteristics of this particular subject? When you create an algorithm, it should be pretty clear. When you create this, it should be pretty clear. It should have clear start and end, along with proper defined properly defined steps, and each step of the algorithm must be precisely defined and unambiguous. That means you should know very clearly what that step does. You should not be like maybe, could be, would be, should not be like that. It should be very clear, because your logical brain has the answer for the problem. So that has to be documented, means you should clearly study that particular step by step process. It should be finite and it should be definite, and you should also know what input you get for processing that. Some may not take an input, some may take an input, but you should be very clear what are the inputs you are going to handle and what are the outputs you are going to give after the algorithm is executed. And the steps of the algorithm must also be simple enough to be carried out. Not all complex things are really complex. If you really understand the steps, everything is simple. I'll tell you a classic example. If you look at the mathematics as a subject, that subject will be tough until you don't understand the steps. The moment you understand the steps, believe me, the most easiest subject on earth will be your mathematics. True. I'll tell you one simple example. If somebody asks me what is division and what is multiplication, now I normally tell them multiplication is level 2 of addition and division is level 2 of subtraction. That's what, right? In a simple sense, what do you do in multiplication? You do add. 4 into 4 is 4 plus 4 plus 4 plus 4. That's what, right? Fine. 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. 4 4s are 16. So it's a simple addition. And what is division? Fine. 20 divided by 5. That means you have to deduct. True, right? Correct or not? You have to deduct. So division is level 2 of subtraction, multiplication is level 2 of addition. If somebody had told this in my first standard, multiplication and division would have been easier, and thereon everything else would have been easier. Correct or not? So simple, right? So the steps have to be very clear. If we understand the steps and if they are simple enough, believe me, we will be able to have an effective solution. And we should also know the finite amount of time and the finite amount of resources which we are going to use in processing that step by step process. Got it, guys? Okay. So based on this, we can also arrive at some patterns. So Al-Khwarizmi has given several types of algorithms. Right now I'm not going to go in depth on this, but just a listing of the types we are going to see here, because they are going to be tough for you. So at this point of time, so I'm going to just touch it on an overview stage. There are something called as types of algorithms, in which one of the type is simple recursive algorithm. Now why do we need these types? Because when we are trying to understand the algorithm, if we try to relate this with some of the types, then understanding that step by step process will be more easier and more effective. So one type which algorithm says is simple recursive algorithm. There is a difference between iteration and recursion. Remember this, I will touch upon this later. So recursive algorithm means solve the base case and then solve larger cases by using recursion. So you apply the same thing on itself so that you can solve a larger case. And second thing is divide and conquer problem. You divide the main problem into sub problem and solve the sub problems and then combine the solution. You want to boil 10 liters of water. Rather than boiling 10 liters of water in a 10 liter can for 10 minutes, you can boil that in 5 cans. Each can hold 2 liters in 5 burners. In such a case, you can boil the same water of 10 liter in 2 minutes rather than 10 minutes. So that is an example for divide and conquer algorithm. Why are we learning this? Because all my algorithms will fall under some category other. If we group them, then it is easy for us to understand. Then you got dynamic programming algorithms. Get to know these types. Later part it will be useful for us when we discuss this. So in dynamic programming algorithm, we solve problems by breaking them into simpler sub problems and storing the results of these sub problems to avoid redundant calculations. Now this is not divide and conquer. Of course it looks like divide and conquer, but not. Dynamic program mein the result of one will be added to the result of the next. The same divide and conquer problem can make use of dynamic programming, can make it more easier. Like for example, it says, see, the result of 1 is added. Storing the results of these sub problems to avoid redundant calculation. I'll tell you in a simple sense. Instead of boiling all the 10 liters fine in 5 cans, what I can do is I can boil 1 liter in 1 liter can, 2 liter in 2 liter can, 3 liter in 3 liter can, and then 5 liter in 4 liter in 4 liter can. That way you can see 10 liters boiled in different cans. Now what I do is I boil that 1 liter in 1 minute, correct or not? By that time the rest of the water would have got boiled half way through in other cans. Now you place that 1 liter boiled water in another vessel, then you transfer the 2 liter cans, 1 liter water in this 1 liter can and 3 liters waters 1 liter in the 2 liter half empty can, and then the 4 liter can be added to this 3 liter can. Now what is happening is here already boiled water is getting added, fine, and then instead of boiling it fine completely, you are boiling from 50%. Now this is another way of handling things, because there might be cases where you may not have same size of cans or same capacity of burner. So when you use divide and conquer algorithm, by adding dynamic programming to it, we can make it work better. So that's how the algorithms are, guys. Algorithms are basically the intellectual processes which humans follow in order to do the job effectively. Now we are trying to understand the human power, the human brain's power. So all are interrelated only. We need to understand the difference. Right now it will be too much for you to understand everything. Just understand what I said. Repeat, go through this video 1 or 2 times. You will understand the concept which I mentioned. In most of our houses, our mothers do that. Both divide and conquer and dynamic programming algorithm they would have practiced in their kitchen. Just try to understand this. And next is greedy algorithm. Greedy algorithm is the one which I discussed in the ATM machine example, where the person goes for the highest denomination first and then goes for the next highest denomination, gets the job done in the least possible time. So that is what greedy algorithm is. We'll talk about it later in depth. The fifth one is brute force algorithm, where we try all possible solution until the correct one is found. So we mix and match. Every day our mother does this, right? She mixes and matches and finds out different combination of food which the children like. So that's actually a brute force algorithm. Then backtracking algorithm. Build a solution incrementally, and whenever you have a problem, you again come back like a time machine, like what we do in games and all. So we come back, correct it, and again forward. You come back, correct it, again you move forward. We call this as backtracking. They say, a goat when it fights, it goes back, not to run away, but to attack with more vigor and more strength. Similar to that, backtracking algorithm is we try to understand what went wrong, we try to correct that, and if needed, we go back and again come back front. So these are different types of algorithms, right? These are different categories of algorithms by which humans generally solve problems using the logical thinking. So that is with respect to algorithm. And in case if you are going to use this, believe me, you are going to understand the way by which your logical brain work more efficiently. Now I am going to stop with this with respect to algorithm at this point, but believe me, this is the study you are going to do for the next rest of your life. So everything in your life is going to be in understanding one or the other algorithms. There might be so many algorithms you will come across in your life. We will try to understand them as we move on. So again, let me repeat what at all we have covered. 4 basic pillars of programming we have covered. Now I am just trying to tell you one thing very clearly, guys. Whether you are in IIT-BS or whether you are into NPTEL, or whether you are into learning any IT programming subject, or you are an IT aspiring student, or you are a school student, for all these 4 pillars, understanding of these 4 pillars is must. What is the first pillar? Logical thinking. Second pillar is computational thinking. Third pillar is your data science. Fourth pillar is algorithm. These 4 are common topics. If you are going to understand them, definitely the rest of the things are going to be cakewalk. Got it? Fine. Now let's move on to the real subject. In this topic, we are going to talk about, first to start with, data types. Now this is the start of your programming. Now believe me, this programming topic which I am going to cover, I will make use of Java language to make you understand it better. I need to demonstrate that, right? So I will use Java as my base, because why Java I am taking is because a lot of people fear Java. So I want to remove that fear from you. So for that reason, I will use Java to demonstrate all the programming exercises which I am going to perform. But my objective is not to teach you Java here. My objective is to teach you programming. So for you to qualify your IIT-BS qualifier exam, to clear that qualifier exam, you need to understand the basics of programming. That is, what is data type? How do you initialize the data type? What is a variable? What is a decision? What is a looping structure? What is a conditional construct? What is a ternary operator? What is a while loop? What is a do while loop? What is a for loop? What is an array? What are operators? Arithmetic operator, logical operator, relational operator. I need to have the understanding of this. Without the understanding of this, I won't be able to process data. Please remember that. And your IIT qualifier exam will have a processing logic given, which will perform some operation on a data set. Now you need to do a dry run without a computer or a calculator, and then tell the result, what exactly the output will be, or what exactly the answer will be for the question. Now believe me guys, many students do practice using a question bank and deliver the results, and they can clear also. See, if passing is the objective, believe me, with your experience of having 12 to 14 years of education experience, you will definitely pass. See, passing is not the objective of me getting into this. you should not only pass, you should also gain knowledge. So take this chapter seriously, go through that, understand the subject. Once you understand, probably then of course we are also going to practice the questions, but with understanding. And after which, if I make you practice 10 problems, the rest of the 10 problems you will be able to solve on your own, because real life is not copy paste. Real life will be challenges, every day new challenges. Now to address and solve those new challenges, you should have a strong understanding of the fundamentals. So again I am repeating, we have completed logical thinking, we have completed computational thinking, we have completed data science, we have completed algorithms, all basics, ABCD of these things, and I call them as the pillars of computer science, without which you cannot move forward. And what is that we are going to cover next is the art of programming. Now that's where we are going to start with data. After data we are going to talk about process. After process we are going to discuss the output. Once that is through, believe me, you are through with the level 1. And level 2 we are going to make data sets, and we are going to address complex processing, complex data. In level 3 we are going to address the question papers which IIT-BS has, and also other exams related to that, similar to that has. Once we solve some 10-20 problems, believe me, after that you are going to be a pro in data science. Not only this computer science, this computational thinking subject, you will also be a pro with respect to your computer career. So again, welcome you guys. I hope till now if you have traveled with me, I am sure the rest of the classes also you will travel. Now in another 4-5 videos, believe me, IIT-BS qualifier curriculum will get over for you, and with that you are ready for minimum of 15 to 20 marks. Will that not be good enough, guys? The rest of the topics are going to be English, mathematics and statistics. Once that is also over, before this month end, or rather August 15th, you will have your comfort level, and after which you can take a revision and take up model test, all those things, and then get a confirmed mindset that you can write the IIT-BS qualifier exam on October 27th, for which you need to apply before September 15th. Believe me, if you are going through these videos, I'm sure you will be able to finish off this. You will be able to successfully get. My objective is not just make you take 50% pass marks. My objective is to ensure that you all score more than 80 marks. Now believe me, whether you are 50 mark student or 40 mark student, it does not matter. Follow these videos, I guarantee you, believe me, you will score more than 80 marks. Just follow these videos, that's more than sufficient. Put your doubts and ask me your doubts. Once again I am repeating, we have covered 4 pillars. What is that? Logical thinking, arithmetic, computational thinking, and then we talked about data science, we talked about algorithms. Make sure you are completely thorough with the what is what of these topics. Thank you very much. Wait for the next topic. Thank you guys.